it in and just play them all from there.
So right now I got a separate wave board with an SD card in it. I got all the sounds, all the steel guitar licks pre-programmed in, right? And I can do the same thing for the bass and stuff like that. I've just been really working more on I learned to play dobro and getting the bass. Right? I'm not that great at bass, so I'm getting my bass chopped up, and fiddle steel, that's my main instrument, so that's no problem. But anyway, just trying to get it all coordinated and trying to add reverb in real time and all that kind of stuff. So I've been working on 1,000 different things, but it's fun.
Well, everybody, let's start the Propeller 2 live forum. We have probably a lot of little topics today, nothing in particular. Chip just sent me a message about half an hour ago, and he's not going to be able to join us. He's on his way to the hospital, but he sounds okay. He has a appendix type flare-up issue, and he wanted to come to the live forum. I said, it's okay, Chip, not today. Take a break.
He's been pushing himself so hard. He's wearing himself out. Like
you know too. I mean, the rest of his story. Yeah, he's really overdone it.
I got text messages from him at 2 a.m. the other day asking questions about what he was working on. I'm like, dude, go to sleep.
Yeah, he has this 25-hour clock cycle that is his own, and he's had it his whole life. And he, days become night, night becomes day, and he just rotates around. And well, it's not really healthy, but he doesn't have other bad habits. Just his sleep, and his propeller design obsession. So we gotta work on him to take care of himself.
Well, I know part of it is that he's very enthusiastic with these debug things. We talked a couple of years ago about how to visualize programming to make it easier, different from how Blockly does it with the visual blocks, but like something more advanced. And this is a piece of that puzzle, being able to visualize the outputs in meaningful, useful ways. So he's really enthusiastic on it because of that, and he's pushing himself, and he needs to like go in steps, I think.
Exactly, yeah, and just slow down a little bit. Yeah, he puts a lot of pressure on himself to deliver what he's trying to do.
And the thing is because Spin is now not in ROM, he can ship it, with a version, and then come back later and add these additional debug enhancements, and it won't break anything, right? It just adds more.
The pressure's off, yeah, in that way. So I'll let you guys know when he sends me a message about what's up with him, but I think he's going to be just fine.
Yeah, I hope so.
He can't answer any technical questions. I mean, I accumulated a couple from customers that I'll share, and I know we have Ray's going to share the blade today, and maybe Stephen will share his board as well and add just a couple minor items. So maybe we'll do my busy stuff first, then we'll switch into something important. Does it sound okay? All righto. Yep. So anyway, these chips are coming. We get our production chips in just a couple of weeks, which is pretty much planning our kickoff with the P2. I really feel like we don't have everything together in a way we need it to be. Things we do have would be like the website, the hardware products, but we're still short on, objects getting started type of material, but that's just going to have to be where all of you guys are tremendously valuable to Parallax, to be honest, because you understand the P2 and you've been involved with it for so long. So just want to say thanks for that, because you become a replacement for documentation we don't have in some way. And answering all those questions that are going to come up. So one question I do have for you all, though, is we still have a lot of these ES chips in stock, and I'd like to use them on the P2 Edge module, unless somebody can give us some marketing reason not to do that. I mean, what are the thoughts there?
They ended up being the same. Like there was no change between these and the final product, so I don't see any problem.
Okay. Yeah, that was my thinking too. I mean, maybe some would be deterred engineering samples, but like you said, they're the same thing. Okay, no one sees a real issue with that, then we're just going to
And
consume them.
Ken,
Yay, Ray.
just in case some engineering people understand what ES stands for, because most people won't, I just wonder whether you should, if you're going to, then you should put a comment or else leave it for the rest of us to use, because people that are going to buy our boards to start off with are not going to realise there's a difference, or they will realise there's a difference and no, there's no difference, in fact. I'm just wondering whether it might put a stigma out there. Oh, look, they're using their engineering samples.
Yeah, that was the concern, and I haven't checked how many we have. Someone can actually look it up on our website. I think they're all shown.
The last time I looked,
would,
there was about 2,000. That was a couple of weeks ago.
Yeah, I'm
and say
also
if
squirreling
it's
some
not
away.
that many, I mean, a couple thousand. I don't know what your rate of sale is on, like P1s are probably higher than P2s, obviously, because it's not officially out. But I can't imagine that 2,000 lasting very long once things get going.
Well, what I'll do is I'll verify how many we have, and if we really have a lot, we'll look into using them. But I'll also offer them to anybody on the forums for any application you want at our cost. I mean, many of you won't mind. They might be buried in something you're making. And what I don't want to do is discount them on our website and sell to the general public, because it sends kind of a mixed message about our efforts. Like, what? They're already cutting losses on this, and that's not the case. But I really don't want to sit on them. They don't do any good at some point. So we could offer them all to you at a very lower price if you want them.
I wasn't asking for a discount, Ken, but I think
I know,
we should
you're
use
questioning whether or not we should
on the forum. We should just use them up for you.
Yeah, well, so I've got them, and if anyone wants to get these out of the regular online ordering way, just contact me and I'll cut you a deal you cannot refuse. Cheaper than a Starbucks coffee, Johnny Mac. At least the kind I buy. I don't know what you buy.
Starbucks isn't coffee; it's sugar with coffee flavoring.
Yeah, well, those are expensive, but like the bare bones things are $2, right, or $3.
Man, that's what I have.
If you want to sell them, Ken, just add that bit of nostalgia with them.
Yeah.
I mean, as long as you're up front telling them, they're engineering samples, there's no reason they shouldn't sell for regular price.
Yeah, good point.
Especially since they are identical internally to the final product, right? There was no change. It was possible that there might have been a change at one point, but there's no change. So I to me, they have the same value.
So the consensus is communicate, and then special prices to anybody who wants to get them offline. Then, so
yeah, and
use them on the edge if we need to.
I mean, if you're really worried about it, you could maybe make up some edges and then with these on them and have those be only for like us forum people, right? If you and don't put them on the site, right? Put them, just have us call in to order those ones, because I'm totally fine with ES boards.
The Edge and the Johnny Mac, to become available by the first week of November, will have to use the ES chips, because that's what we have in stock, and these don't show up until second week of November.
That answers it. You haven't got a choice.
And in terms of the explanation, you could make a point that the design was perfect, and we didn't have to make any changes from the engineering sample to the main order.
Good. Okay.
Or technically, these were the second or third engineering samples. Weren't very many of the first one.
All right. So noted. And it really helps that you're all aware of the realities around this too. So, oh yeah, and just I mentioned this last time. These guys are going to be selling everything for the Euros owners who are probably not here right now. They'll appreciate this, but there's a list of 14, well, whatever, 11 products we're putting in a DigiKey and Mauser, and that we will be releasing in November, which you're all aware of. So, including the silly little connectors. In case anybody wants to get them, we're buying those at a low enough price that people want to get them from us for less than a couple bucks, I think. So we'll have those too. Have you seen this yet? Has anyone seen this?
I think we saw an early version of this.
You did? Oh, yeah. So this one's actually going off to get fabricated today. And so Michael and Chip designed it. You guys can see what's on it. Someone talked me through it. All I've seen is a bill of materials.
So it looks like it has 2 or 4 of the connectors that are the same as what was on the eval board. And then it's got the 2 banks of servo connectors between those. And then you got the big edge connector thing in the middle. There's a prop plug connector. And then there's another, is that another one of the, I think on the end there next to the barrel jack plug, I think that's another eval board.
It is.
One, except it's slightly different because it has the reset pin.
Which makes it compatible with the WX Wi-Fi?
Yeah.
Probably for the WX Wi-Fi board, yeah.
Steven, this doesn't obsolete your design though.
Yeah, no. That's
Okay.
why I did it, because it works there too.
And this will be fully assembled by us. It's all through hole. So
it's interesting that there's 4 rows of 4 pins in the rows in the middle for the servos.
These guys
normally only need, the banks, those that you're circling right now. I wonder why it's 4 instead of 3. I wonder if there's like a extra thing there.
Looks
like an extra power or ground.
Yeah.
Or it's a prototype area. You'll have to ask the designer.
Yeah.
But in the previous version, those were mentioned as being places to plug in servos. But maybe the extra pin is power input for them because you don't want to power it from, I don't know. I don't know what they could be.
It could be for a I2C bus.
Possibly, yeah. It could have clock data and then power and ground.
Well, while you guys are chatting about the blade, I'll go round up the schematic.
Yeah, that would help. Or even just seeing the traces on this board would have helped a little bit, but I think we've figured out most of it.
And then there's this too. So this is just a bag of parts, and it's going to be the vertical header plus some single inline male headers. And you can populate, it looks like either column of these, but not 2 if you're going to put it into a breadboard. So that's just a low cost thing. And then I think when we ship this, we'll probably include a right angle 4-pin header for prop plugs on the P2 edge. So I'm on a kind of on a need to know basis right now because I told all the technically minded people that they can't make any more boards now. The jig is up, including my boss. I told him at 3 a.m. So
who's your boss then? I thought you were the boss.
My boss is in the ER room right now.
Oh, okay, so Chip is actually still your boss, even though you're the president.
Mm-hmm. Yeah. You learn your bounds and limits and know how to get along.
Aren't you the older brother?
Everyone thinks I am because I'm, quote, the more responsible one, but he's 2 years older.
Oh, okay, wow.
So, then we have this cool thing.
Ken, but before you move on to that, back
Yes,
on that
sir.
other board,
Yep.
What was the one before this one? What was the purpose of a prop plug as well as the connector we're currently using on the eval board for loading? And I noticed it has pins 62 3 on it.
So the eval board is programmed via USB and requires a USB
Gotcha.
chip.
Gotcha.
This
Okay.
one doesn't. So the prop plug has the USB chip, so it goes directly to the serial pins.
I got you. Thank you.
Yep, and we put a reset button on here for MS Robots, right? Isn't he after the reset button?
Well, the reset button is super handy.
Yeah, others wanted it too. No reset button here, so we won't look at that too hard.
But that's fine. That one's meant to be just a way to hook up the edge to a normal board or the breadboard, and you put all your circuitry on the breadboard or your other board that this plugs into.
Okay.
So it's fine that this doesn't have anything. It's just the simple straight through thing.
All right, good. And this we actually named as such because it can be used with a microbit as well. We called it, well, we argued inside. Some wanted to call it the 80-pin mini breakout. But I said it's really for the P2. So let's just keep the family together and give them names that kind of go together so people know what it is.
Right, and then just in the store page, you can say could also be used with the microbit.
Yep. Perfect. Before Ray gets going on this, Brian, you had a question about generating sine waves on 2 pins that are the same. And
yeah.
I asked Chip, but he didn't reply back. So I don't know if anybody else.
That's fine.
Okay.
But if anybody else knows, can the if you've got a sine wave running out on a single pin, could I go to say 2 other pins after the first one's already running and put a sine wave out on them and them be in phase with the first pin? Is that in the smart pin structure at all, or is that?
I think you could do it if you start them all at the same time. You could get them in phase, but not if you have one already going and try to start 2 new ones. I think that'll be more difficult, but you can start multiple pins simultaneously, and the smart pin logic will fire on all of them in phase.
Okay, yeah, that was my yeah, I'm just curious about that. Now I don't want to hold everybody up over that, but yeah, that would be no, it's not a showstopper for me.
Sherry Hitt has a thread in the P2 forum now about using the streamer to generate a sine wave. So you may want to look at that to see if the DAC configuration will allow multiple pins, since it does use kind of smart pin modes. But I don't know if the streamer can send data to more than one.
I saw that, I glanced at it, but the streamer is kind of way over my head right now.
Yeah, the streamer is sort of complex, and I'm almost positive it can go to multiple pins. Like it can do parallel streaming to 8 pins. I'm pretty sure they had an example, or Chip did that on the FPGA at one point.
Okay, but if you were, Brian, if you were just manually doing it, so say you had a code loop that was going to talk to a pin that was set up in a standard DAC mode, then you could set multiple pins using a pin group into that same DAC mode, and then do, when you're doing the WX, you know, the write X command to update the DAC level, you do it to the pin group, and all of them would be updated simultaneously to the same value.
If I started, say, 6 pins with the same sine wave, is there any way with the direction registers to like shut 5 off till they're needed?
Technically, yes.
That may be the way I need to go.
Yeah. You know, you start them up all at the same time, and then set the you know, turn off the Durbit so that you put the smart pin into reset. Once you put it back into a driven mode, then the smart pin would reactivate.
I'll have to try that. Yeah.
The main thing with doing what Johnny just said was or Johnny Mac, sorry, just said was if you put them into reset mode, when you start them back up, they might not necessarily be in phase with the one that was already going.
But if you were writing to them, if your write loop was writing to them as a group, then they would be.
Yes.
So what I'm saying is create a pin group.
If you set it up where you're actually writing out the sign information to the pin group, then disabling them with the dir set would work. And then when you re-enable them, your code would be continuing to output and they would be all in phase with each other.
Yeah. Yeah.
So yeah, Johnny Mac.
The application I'm considering, like I said earlier, last week, week before, was an inverter, and I see a lot of people want to use different ways to compensate for extra load. My idea was tinkering with putting FETs in banks, and say I only need 400 watts, then I only use one bank. But if the load doubles, then I can activate the second bank of FETs and, drive a deeper load. But they would have to be in phase with each other for me to do it that way. So as to keep down on heat when I'm not really using, if I'm just running a radio, then I don't need something capable of a refrigerator. But if I had it there and could activate it when it was needed, that was my idea anyway. But that's great, guys. Thanks for that feedback. I appreciate that. That's great.
Bring more. Good questions. Before we let Ray go, and also Stephen's going to share his picture at some point, his design. I have one customer, vision impaired. I don't know if anyone has any experience with this, but I was using the Propeller tool with Windows with a screen reader quite well. Windows upgraded to version 10 and nothing works anymore with the screen reader. And this is kind of important because some of our largest customers are actually vision impaired students in West Virginia, and the state sponsors them with BOBOTs. Because our basic stamp software is usable with the screen reader and the Arduino is not. So thinking about how to help this guy out. I don't even know if he's here or not, but does anyone have any experience with that, screen readers? None, right? Okay, all I suggested was try the Propeller IDE from Brett to see if it behaves differently.
It's a little convoluted, but perhaps he could run an emulation and run an older version of Windows in the emulation.
It's interesting that the same prop tool software fails to work with screen reader now.
Oh, I don't know what to say. I don't know.
So let's find out why it doesn't work.
I'll ask him for more specifics.
Yeah, so put it on the forum, Ken, and put some links and stuff so we can try it out. I'll spend some time testing it, see what we can figure out.
Have you used a screen reader before?
I have, yes.
Okay.
Might be able to run prop tool in a compatibility mode, like when you right click it, you can configure different compatibility modes on the executable when you run it, and maybe running it as if it's in Windows 8 or Windows 7 might cause it to then function again with the screen reader.
Exactly, yeah.
Another thought that comes to mind is by pressing Control and rolling the mouse wheel, the font could go up and down, and maybe the DPI is not jiving with the screen reader.
Oh, okay, and in the Propeller tool, what is it? Shift arrow? Someone help me there, I forget. To increase font size.
I think it's I do it with the
mouse wheel.
Mouse wheel or Control mouse wheel. I forget.
Yeah, I think it's control and then the mouse wheel up and down scales the font up and down.
Okay.
That's pretty standard in Windows for a lot of apps.
That's good. That gives me a lot more to talk to him about than I had 10 minutes ago. Great. Well, shall we go down under to Parallax South and hear about the blade?
Okay, taking it away. What's the function that I bring the screen up on, Ken? Where's the
green button in the bottom of all the squares with all the people.
Right. Okay, and I need to change my focus.
And while he does that, just a Zoom tip for everybody that so you know when you register for these meetings, you're allowed to come here before the host is joined. And many of you show up sometimes hours before and you say, Ken, the meeting started, why aren't you there? So I think when you join a meeting before the host, you get a message saying the host has not started the meeting, but you're allowed to join anyway. So
Okay,
don't be alarmed. That's perfect.
Can you see, sorry, Ken, can you see my PCB layout now? Good, because I can't, for some reason I can't see it, but I've got the little green icon up the top. Okay, this is my board as sent to production. So what I thought I'll just give you a brief rundown of what it was intended to do. It's intended to be a board that will run a self-hosted operating system. And for that, the only thing missing is actually a compiler for P2 running on the P2. The reason for this is that I've got an emulation of CPM and Z80 running on it. Not fully debugged, but it does run MS Basic. It will do a directory and a number of other things. So it's a carryover of my P1 operating system, plus the fact that on P1 with my RAM blade, where I put 512K of static on it, I could run CPM 2.2. When running CPM 2.2, you've immediately got an editor, such as WordStar, VEdit, a number of other editors. So we can edit source. So the only thing we need is actually a chip to convert his compiler, and we can compile on it. So I presume you can see my mouse on the screen. Yep. This is the micro SD card. It's not that version. I didn't have a footprint for the version we're using. Peter's actually shown a picture of the connector, and I'll show you one in a minute when I flip over to my camera, because I've got a roll of them here. There's two USB ports brought out. You might use one of them to supply the 5 volts because it requires 5 volts regulated. So you can get your 5 volts in either by either of these two, or using the pins on the side. So there's a 5 volt and ground on the side. So these top 4 pins are 5 volt ground, 5 volts, 3.3 volts, and ground. 3.3 is an output. So you could use the top 2 and provide 5 volts on either side, or you can provide 5 volts in this center section here. Now this is not a prop plug. It's the real cheapy $1.50 version. How can I flip back to the camera, Ken?
You're muted, Ken.
Thanks, Roy.
Okay.
Back to
How do I flip back to the camera?
Yeah, share screen, and then you should be able to. Do you want to turn it off and then use the camera that's pointing at you?
Okay. Does that bring? That's brought me up. Good.
Okay. Then let me try to maximize your video. I don't know the difference between pin and spotlight video, but is he large now for everybody?
No, you need to spotlight him.
Spot it. That's it. Okay.
I can go up close to the screen. It usually works pretty well.
There we go. Now he's spotlighted.
Yeah, so what I'm trying to show you is this little board here. So It's $1.50 on eBay. Reliable. It's a 6-pin CP2102, and I bring those pins out. Now, there is on that board a 3.3 volt on it. You can't use it. It's about 10 milliamps or something stupid, so it won't run anything. But it does bring the 5 volts from the USB out. It's got transmit, receive, 5 volts and ground, of course, receive, and DTR, which allows us to reset the prop. The catch is with the prop tool, we need the prop tool, prop plug has the transistor reset circuit. You'll notice all my boards for years now have an optional reset circuit. So if we go back to this header, so back to share screen. So this header here is the 6-pin header on that cheapy serial USB to serial port. And I have over here the little transistor reset circuit. So there's the transistor. And there's a little 3-pin 0.05 inch or 1.27 pitch, so the half size pitch, where you can put a link on, and the Q is marked for using the transistor. Otherwise you need to link the other two. Now, if you're always going to use a cheapy USB serial, great, you can link it by just linking the board directly with a little solder bridge. But if you want to make it optional, you can use the little 3-pin header and shunt. Now, the other little thing, while I'm at the same point, I've got this little jumper here. This is smaller. Let me go back one. Sorry, you don't have the option. That's smaller than the 0.1 pitch, 0.05 pitch. So you've got to solder it based on the fact that you're probably using one or the other. You can't change them around. This one's got the 0.05 pitch. The reason for that, this is a flash chip. So if you do fit the flash chip underneath the board, which I'm not planning to normally do, then you need to jumper the resistor, the pull-up resistor, so it will boot off the flash chip. So you might want to be able to change that so that's on a header, so you can pull the link off. So that overcomes all of that. So now what have we got with our I/O ports? We go from 0 all the way down to 15 down here, and then we've got a ground sitting in the middle, which you typically won't put on, and then you come across here. So the left-hand side's got 20 pins to there, miss one, and then we go across here. If you want to just file that down slightly, you can actually go 20, or you can go 22, and then you can go across here 14. If you want to actually fit all of them. I think you'll probably won't. Now, across the bottom, we continue. So we've gone 15, then we come 16 through to 31. And then we miss a ground pin, and then we go 32 right up to 47. And then we've got our 4 power pins. So that's 48 IOs. Then we've got 2 IOs actually go to this USB port and 2 go to this. So that's 48, 49, 50, 51. Then we've got 6 pins that I couldn't bring out. And here they are sitting here on little tiny non-tented vias. If you really want access to them, they're there. You'll have to run wires to a breakout board, but at least if you really want them, they're there. So that's, what did I say, 52 to 56. So then 57, 58, 59, I've got myself confused. So 63, 62, 61, 60, 59, 58. Okay, the next 4. And they're the 4 that go to the micro USB and to the flash chip on the other side. And then of course you've got the last pair, 62 and 63, and they're brought out on these two pins here for serial out, serial in for your typically USB connection using that CP2102. So that's where all the pins are. Now, if you look at this section down here, when I managed to find where my scroll, well, no, can't do it. So on top of this header down the bottom here, I've got a footprint for the VGA because my prime objective was to have micro SD to boot and a VGA port. So I've got that, but I've also got the ability to bring the pins out. So you can either solder the pins underneath the board and have a breakout and get these extra pins, and you've still got your VGA cable. So you've got access to the pins. Now the VGA uses the top 5 pins of the row along here. I did that so that I had the maximum continuity I could get of pin numbers. So the top 4 pins here, so we're going 20, 23, 22, 21 and 20, and then pin 19. So 19 is a vertical sync, and then you've got horizontal sync and RGB. So I shoved them out of the road instead of being down on an 8-pin boundary, they're on a 4-pin boundary, less 1. Let's turn the board over. So you'll see this is a flash chip. That's the link for the flash, which I spoke about on the other side. Here's your 6 little pins that I brought out on just on vias. This is your link for using the transistor reset or using if you're going to use a prop plug. You can see how my VGA port overlays over the top of these group of pin headers here. So if you extend them down under the board, you can leave them in and have access to them. You could put a right angle connector. I don't know whether I've got right angle pin headers in stock or not. If I do, I'll shove them in the package because they're worth a dime a dozen, unless you're buying them from Mauser or something. Okay, let's go back to looking at some of the design philosophies behind this board.
Hey, Roy, did you get your question answered?
Oh, it was just a quick question about if you power it with USB, does the 5-volt pins on the edge, are they now outputs of 5 volts?
Yes, they are. They're all in parallel.
Excellent.
There's no jumpers or anything on the board.
Cool.
Okay. While we're talking about power, one thing I neglected, this is the power to the chip. So up here, I come in, I bring in 5 volts, I regulate it down to 3.3 with a SOT 223, which is a 1 amp regulator. There's plenty of copper on the board, but I'm just using standard 1 ounce. From the 3.3, we come into the second regulator, and that regulates it down to 1.8, and that's 1.8 volts used by the logic on the P2. The 3.3 volts for the I/O comes through a separate regulator. So I'm not hammering this one. I'm trying to take off the load from this 3.3 regulator. I've got a second one, which is a SOT 89, which is a smaller regulator, still 1 amp, but you're going to use a lot less in the I/O. And it drives the I/O pins for the propeller chip and the flash chip and the USB and the SD. So Let's come in here, turn off the bottom. This is all ground, so you can see the ground all comes in and runs around the chip, and it will actually run down all those wires around the chip there on the underside. All my bypass caps and bolt caps, so that's a bolt cap on the ends, and all the others are bypass. They probably don't all need fitting, but there's one on every power pin on the P2 to do proper decoupling. This is a little crystal, it's a 3225 surface mount crystal. And we'll go back up to here, get that in focus, and I'll show you what the bottom looks like. So on the outside is the ground. So see, there's all the ground wires I was talking about. Down there, along there, along there. Now I bring in the 3 volts. This is a 3 volt coming from that smaller regulator, and it goes right around the chip, supplying directly into the capacitors there and there. You can see it comes in. So we're getting a good, nice supply coming in there. The 1.8 volt comes in here and goes again all around the chip. And you'll see, so there's the 1.8 connection in here. The ground in the center is isolated. There's all the feed throughs to bring an extra pad underneath to get as much copper as we can, but we can't really bring the copper around the outside without upsetting our power supply. So, and there we have the overlay. Now, you might see that, notice that all the text is reversed. That's because you're looking from the top down, not from the bottom up. If I turn the top silk, turn that, go to the top. Okay, and there's the top side. So, are there any questions?
So which 3.3 goes out to the outer pins? You have the 2 regulators. One of them is just for powering the 1.8 into the chip, and the other one is everything else?
It's solely for the 1.8. But this TO223 goes out here straight in to the input of the next regulator. It doesn't go anywhere else other than the bypass capacitor, the bulk capacitor.
Okay, cool. So the
3.3,
3.3,
yeah, 3.3 is the IO 3.3. So for all intents purposes, these pair of regulators could be in one package generating 1.8 volts, but I want to spread it to spread the heat. So I did some testing, and just in free air, I can get over 500 milliamps on that combination without causing any stress at a typical 20 to 25 degrees ambient. So I've got no concerns that the majority of people are never going to run into an issue.
Yeah.
There will be a few that will push this chip to its nth degree. We did that with P1. I think this chip's a lot more powerful. We'll find that it will be hard pressed to run 8 cogs running hub exec, streamers and everything else on there to push the power limits up to where beyond this board can handle. But it's a cheap board. It's only a 2-layer board. And it's designed, as I said, I've called it a RetroBlade because that's one of the main things it does. I haven't quite showed you the final board because I did a change to the silk screening, and that'll be a surprise when it comes out.
It's a lot of stuff packed into a small space.
Yeah, there's more space on there because I originally targeted this board. I started off with being 1.2 wide. Then I found with my regulators, I couldn't fit the stuff in. So then that grew and ultimately it was 1.5. And then to put the extra set of headers down the bottom and bring out another 16 pins, I thought made sense. And Peter suggested putting under the header. I tried putting RJ45s on. They worked. But then I came back to, well, if I extend it to 2.2, then I get my full 16 across. That means I've got to move each set of pins out 50 thou. So I extended the width of the board to 1.6. And I'm happy that this is a nice size board. I mean, 1.6, I'll flip over to the, how's that? Yeah. Okay, that's a 2-inch square board. And to give you a reference, that's the Propeller 1 chip on it. So we're actually talking about 1.6 wide, which is, if you can see where the ruler is, knocks it off. So that's 1.6 wide there. And you've just got to add 2 more rows down the bottom to get you to 2.2. So it's a pretty tiny board. While I've got that on there, I'm going to show you, oops. Hang on. That is the micro SD socket. It's an LGP, I think it's about 7 cents.
Wow.
It takes up a lot more room on your board. It doesn't take any more physical room because you've still got to plug your micro SD into it. But it takes more physical PCB space, but it fits on that board nicely. By comparison, I'll just move my camera around. By comparison, where's okay, there's 3 footprints. Sorry, I can't hold it any stiller than that. So that's your micro SD. That, beside that's a micro USB. And then there's a big chunky VGA. Just where there. Oh, where do I get? There. That's a 3D printed logo.
Looks like a very tidy design, and it's nice to see the VGA just right next to the P2 without a lot of connectors and accessory boards.
Yeah. I figure that there's a lot of people playing around with retro stuff. It interests me more for the retro of it, not for actually using the CPM stuff. So I haven't actually done much with the CPM. I was a user back in the early 80s of CPM. I designed Z80 and Z8 boards and programmed them. I did not do anything with CPM other than use it as the as a tool for my development. We built comms cards, company I started up, Netcom. We built communications cards to go into IBM mainframes that plugged inside Apple IIs and Apple IIIs, and we sold it to Apple America. Now, I did take you around the chip and showed you the bypass and the bulk capacitors, but I wanted to actually show you a little more on that and take you through some of the philosophy behind why you build a board and put bulk capacitors and bypass capacitors, and why a bulk capacitor is not a bypass capacitor, because there is some people that think otherwise.
Couple of quick things, Ray. From the messages, are you using KiCad right now for this stuff?
Yes, it's my first foray into KiCad. I've used Protel for years, like 30 to 40 years. But I use KiCad. I call it KiCad, but I found the correct pronunciation is actually KiCad, and I'm trying to say it, but I usually stuff it up and get it wrong.
I've heard arguments both ways. Then the other thing I had a question about with the VGA, can those slim VGA connectors fit in the same pinout on your board?
No, the slim VGAs are completely different. Here's that's a slim VGA on a board that Lachlan produced, tubular.
Oh, nice.
And you can see how tiny they are, but they're a totally different footprint. Their mounting is a little soft, but they're very expensive connector. And I've gone for cheapness. I've gone for simplicity. It's why I haven't used switching regulators. Switching regulators can introduce noise, so then you've got to take very special steps around to minimize its noise. And I just basically decided that's not where I'm aiming.
That makes sense.
Yeah, we've had trouble designing around switching regulators too.
Yeah. Okay, so going back to this one. Okay, I laid out this morning a dummy board to try and explain why you use bulk and bypass capacitors. So here we have our power coming in. We've just got a simple AT tiny chip. We come in, that's a bulk capacitor. So the idea is we come in through a bulk capacitor, and then we have a bypass capacitor. The bypass capacitor is the closest to the pins on the chip that it's bypassing. You try and squeeze it right at particularly the VCC pin, usually because you've got a big ground plane. It's less important to have this pin close to here, although you want it as close as possible. But this pin here wants to be right on at this pin, if at all possible, because that's what's going to bypass the noise. So when this chip switches, when all the MOSFETs all switch, they generate noise and they generate high frequency. You know, classically 10 or more times the fundamental switching frequency. So classically, the old micros used to switch at a meg. So 1 megahertz, say you're talking about, you've got to bypass 10 megahertz. We're talking about 100 megahertz chips, 200 megahertz chips, 300 megahertz, even with the P2.
No wrong, but I can't use it. That's a C. This is a B.
So you're going to you need to bypass around the gigahertz region. So a lot of the fundamentals say this cap should really be 10 nanofarad, and you should have some of each. I haven't quite gone to that philosophy. I can do that in my P2 design, but I think that the hundreds will be fine. But definitely you need bulks as well. Now, to show how that layers up, here's what you really should be doing. You really should be coming through your pad. That forces this capacitor to do its job the best as it possibly can. If I was to bring that down there and just drop that across there, that capacitor doesn't quite do the same job as it does by coming through the capacitor. And that's what I've tried in all my designs. Now, my P1 design, I regularly clock it at 104 megahertz. But I've got specific bypass. I can't do that with a normal Prop 1 board. And that tells me that I've got it right. So down here, come into the 5 volt, see how I've brought the ground in. So that's it. Now, if you want to go to a little bit more about that, I'll flip to another screen. Here's this one's from AVX, and they quote their capacitors, and you can see how they're talking about this little dip here. This is a 0.01, and they're talking about probably about 50 megahertz. You can see the little difference we're getting here with the case styles. And I saw a better graph, but I couldn't find it, where it shows a little better, and the 0603s, even the 0402s, get a little better with their impedance. Now, if you look at, so that's an 0805. So here they're putting 1,000 puff and 10,000 puff, so 0.001 and 0.01, and you can see how it shifts shifts higher for the lower value, and that's what we're trying to do with the bypass. You'll see if we look at a 10 mic, it'll be over here somewhere. I don't know whether they've got a 10 mic on here. I don't remember. No. So, yeah, and that's a 10 mic, 16 volts. We've got they're all 10s. So what we're really trying to do is to really, a bulk capacitors like we've got, you've got a big jug, and then you've got a cup. And the big jug, you can pour a lot of water out of it, but the cup is going to only give you a little bit of water, but it's going to soak up the drips if you're dropping something into it. So it's not a real good analogy, but so you really do need to have both capacitors in your designs. I tried to convey that to Chip, but I wasn't successful.
Is it better to think of it as the little cup is able to respond more quickly?
Yes.
To the draw, versus the bulk one is a little slower, but it's able to deliver more.
Yeah, exactly. Now I'll flip back to, okay. Here's a board. Some of you will know I used to work on some ICL mini computers, and that's a board I designed to put 16 serial ports inside it was a 1980s design. There was a 1969 design, and then a major revamp in 1980, and they didn't have serial ports on it. I built one, sold it around the world. Now, if you look in closely, there's 16 RJ45s down the side, but look at all the bypass capacitors. One for every chip, some of them for more. So capacitor for every chip. They're all serial chips from Zilog, an SCC, if you know anything about it. There's a pair of Z8s on there. There's a dual port RAM, and there's an FPGA that does the interface to the ICL bus. Now, just so you know that that's a 2-layer board. Here's These boards, by the way, sit in anti-static bags. This is an IO board of ICLs. I believe it's a 12-layer board. There's the back of it. These are big boards, but these are mini computers worth, 100, 250 grand.
Is the overall board thickness still the same?
Still 1.6 FR4. These were state-of-the-art boards back in the day, and you can see all those blue capacitors all over the board. They're all 0.1 bypass. Now, I don't know whether I can find. Yeah. Where my finger is pointing, that square chip there, that's a 10 mic tantalum. You can see they're all through the board. There, up there. So they're all through the board as well. They're bulk capacitors. So just fulfills the requirements. Now, ICL made some big mainframes as well, and their guys were really good at laying boards out, as were the IBM guys and the other minis and mainframe designers of the day. So there's 50 years worth of design stuff in there. So I guess is there any questions on that?
It's more of a comment of so based on that discussion that you just explained, your board, the RetroBlade board with all of its decoupling in bulk should be able to handle going at fairly high frequency settings for the P2, assuming you have appropriate cooling if you go above like 300.
Yep,
but you should be able to handle very high levels.
I'm expecting to run my board at 360 megahertz.
Are you going to have any kind of cooling on the chip at all with that speed?
No, I don't think you'll get to a point where that'll become a problem, because I don't expect, with what I'm expecting people to use the board for, to be running 8 cogs. I mean, when you think about what you've got to do to really pump the power up in the P2, you've got to run 8 cogs. You've got to run hub exec, because that's going to hammer the drivers into the bus for the hub RAM, because that means you're accessing them on every clock. So all of those 8 blocks of hub RAM will all be exercised on every clock cycle. So you're really that's going to hammer it. The streamer probably hammers it pretty well as well. You're not going to have 8 cogs streaming data in and out of this chip on this board.
Yeah.
Someone's going to design a special board for that sort of thing, and then you will have to go to switches, and then you'll need a whole extra lot of design around to minimize your noise. So I reckon this board will be very quiet for ADC. I guess we'll see then whether the ADC is really as noisy as Chip thinks it is, or whether we can actually make it quieter. I suspect we can make it quieter.
Yeah, isolating the core power feed from the IO power like you did should definitely help too.
Yeah.
So you mentioned what will the uses primarily be? Are you thinking CPM fan club?
I'm thinking CPM, Z80, Sinclair Z80s, all the different micros of the 80s running on emulation. And
you ought to be able to get Lachlan and Brian's MicroPython running on there, self-hosted with the keyboard and display.
Yeah, I'm really interested in MicroPython. Because I program in Python at my day job now. For the first time in my life, I'm actually working for a boss since '76. I've always run my own companies. Let me go.
And
Yeah,
so these will be available for $40, right?
Yep.
Yeah, I've been doing a lot more Python for work lately too, mainly for our tool sets that the artists and designers use. But yeah.
Okay, if I take that. Oops.
So are you guys all sharing your PCB files or not interested in doing that? Or what's the thinking? I see a lot of work that could benefit others here, and I'm not asking you to share them by any means.
Yeah, I don't know, Ken. I've never done it before because it wasn't possible, because I ran no, I need to go to the front. I'm just setting something up here while I'm talking to you. It wasn't possible to share Protel files because just people didn't have Protel.
Yeah.
But
one thing
I don't know.
Ray, one thing that comes to mind is many of us are starting to use, okay, what's the name? KiCad? KiCad? KiCad, thank you. Many of us are starting to use it, so maybe parts and models, footprints and things like this could be archived where we can all get to, so we're not all trying to find those.
KiCad, the models I've got have all come with KiCad, or I could download them, because not all models are in KiCad, but there's a couple of other model companies, EDA, and there's something beginning with an S, where you can, they'll point you to where the models are and you can download them. I haven't made any 3D models up myself. KiCad uses, I can't think what it uses. I'll tell you in a minute when I close the screen down. Yeah, it has its own FreeCAD. I think it's FreeCAD that they support to use it, and that's what generates these 3D models on here. I'll just go.
I think it would be useful to see all the parallax components, the sockets, and color and things like that.
Well, I've got my. See how I've got the. Oh, let me flip over to the share screen.
Any board we make, we'll give away the files for.
Yeah, Peter's sharing all of his stuff there, Ken.
Great. And also I wanted to extend an offer, which I put in the chat. I'm going to steal the share just real quick from you, Ray, and then I'll give it back to you. Since we're on the hour, we'll give a chip update for intermission here, so you can read it yourself. Chip maybe had too much salty salsa. So he really loves food, especially food from Marco's wife, which is Mexican food, and salsa in particular. So he's probably just fine.
That's good. That's good.
So
that's good to hear.
Yeah, it is. Yeah, you guys are concerned about him. So back to you guys. And also, while we're talking about boards, I want to make it very clear that any board you are building, anyone is building, I want to feature prominently on the Parallax site, and with links directly to where they could be bought, so that we are getting the advertising to you, but without the overhead of us stocking them. So I offer you then a description and pictures or whatever you want to post on our new site. I will put up for you, for anybody. And it doesn't have to, yeah, you're welcome. It doesn't have to be available, but coming soon. Someone's got to.
It's me.
Okay.
I'm trying to clean it up, sorry.
Also still have Ray spotlighted.
Okay. Well, Ray's going to take some screen sharing here, and okay, then mute this.
Okay. This is a standard 100 pin QFP. You
Okay.
can see that screen?
Mhm.
Just I can't. I tried to muck around with FreeCAD as much as I could to superimpose Parallax's chip legend on it.
Right.
For the life of me, I couldn't do it because I really wanted to have the Parallax logo and the big P2 on it. So if anyone knows any way to get it onto the chip, that would be really good. I've shared my footprints of how I made the P2. So underneath the P2, what I didn't show you is how the silk screen layer goes. I'll show you that in a sec if you've want me to. See the little bit here? That's a secret. The board I showed you before was not quite what it is. That's what I'm calling it, a single chip computer. But keep that under wraps for a couple of weeks till I bring this board out. Because without a flash chip, it is truly a single chip computer, and it's probably the first in the world because FPGAs are not single chip either. They've got a load from a flash chip, and I think the ones that are loadable are too small to run CPM. So let's go back to. I was going to show you something. What was I going to show you? I thought of something on the board. Doesn't matter. Doesn't matter. Couldn't have been that important. Sorry?
The silk screening underneath the P2?
Oh, yes. Yes. Okay. So that's the chip. You can see all the holes. Now, what I did, I took an existing KiCad footprint which had less holes underneath the chip because the center pad was smaller, and I just expanded them out and did a couple of tweaks. So if I turn that layer off, right, now you can see this is the actual screen layer. So you can see they're little pads because you don't put a big pad on the bottom of your board. It's very important to get to the right size, and it looked like they'd done the job correctly. That they talk about 80+% of coverage, but you don't put a big blob on. And then all those wires are sitting in the little corners there, so that they don't take your solder paste away. So you still got a big pad. Where's the pad mask? So that's the pad mask, and I'll go put the paste on top of it. So there's your actual pad. So the pink is pink or purple, whatever you want to call it, is the actual exposed gold, because it's an ENIG board. And then when you lay the paste over the top of it, that's where the paste is going. You also might notice well, if you do anything with it, my 0603 pads are slightly smaller than the normal standard size. I used Vichy's pad size to squeeze them down a bit to try and get the right sort of spacing and get my tracks through in between. So that's a little SOT. That's my transistor reset, and it's got inbuilt resistors in it, so I don't have to put external resistors. This is a pull-up resistor for the reset, and the capacitor for the reset is there. So reset is only brought out on this pin here. Comes through the capacitor, goes over to the jumper block, then the jumper block either goes through the transistor or bypasses it, comes over to the pull-up resistor and to the pad. They're my two big regulators and my smaller one. You'll notice I've got bypass caps on the input, directly on the output, then input there. They're not directly on the output there and over the other side. gain when I'm running the 3.3. I've got an input capacitor here. I've got two output capacitors there, one bypass, one bulk. Is there anything else you want to know before I finish?
Ray, it's Johnny Mac. Sorry, I had to step out to take a phone call, so I may have missed this. Is this a 2 or a 4-layer board?
It's only a 2-layer board.
Um,
I try not to go to 4-layer if I can avoid it. And I don't think, I was happy enough with the design. The only thing that I would have achieved better if I went to a 4-layer board is I would have been able to get these grounds here directly to this plane. Instead of that, it does go through the underside to come to a plane. So that's the only difference I've got, is that instead of this going around the ends and in through here to the ground, they would have all come straight across. So I'm quite comfortable that that's good enough. Yeah, it would have been better if it was a 4-layer, but I didn't think there was any reason to go to push to 4 layers. I don't think people are going to be doing massive ADCs on this board. I think more people are going to, they'll trial it, but they won't be, you know, if we wanted to do a proper ADC circuit, really smart in that you're going to lay your own board out for it, and then you will go to multi-layer. So I think that's just about it. I don't think I've got anything else on the desk that I intended to show. Originally, when I suggested this yesterday, I said 5 minutes. What's it taken? It's an hour plus. But then I wasn't intending to go through to all the bulk and bypass cap stuff, but it's probably interesting for you guys to understand what the philosophy is behind it all.
Definitely.
You build it up over donkey's years. And I've been designing boards for just over 50 years now. So.
Well, PC board design is an art form.
Oh yes, and analog is even more so, and I'm not an analog expert. The only analogs that I've really done through the 80s and 90s was modem chips, where we had to separate them, and back in those days they couldn't even put analog on the same chip as a digital. So we certainly jumped ahead and leaps and bounds since then. But there are all sorts of tricks that you do with little resistors or ferrite beads or things like that to try and minimize the noise between one supply and the other. You also have to, if you go into an FCC lab, which I've spent some time in there, and you start to see what radiates and where and why and how and what you can do to minimize it. And of course, minimizing EMI is also minimizing your noise to upset your other signals on your chip. So that's all been quite a learning curve. And so that was all done. Initially, you do that in a lab that's a screened room with wire mesh on all the walls. The doors all have interlocking metal to shield the frame, so you get no outside interference. And then you have little aerials that snoop your board to try and figure out what pin is radiating the signal or what track, and then you try and minimize it. And once you think you've got everything, then you go out into the field, way out. We used to go out to Bringelly in Sydney. Well, you can't go there anymore, there's houses there. But it used to be a massive big field. The only thing you had to watch out for was the emus, because they used to steal your product if you weren't looking. So you'd have them in the middle of the field and an emu would come rolling in, pick up your product and race off with it.
Chip's here.
Sorry?
Chip is back.
Chip showed
Chip
up.
is back.
I'm only half dead.
The Salsa King.
By the way,
salsa dancing there, Chip?
No, it's, I don't know. I think there's something more going on than salt. I feel just like I did before I had that appendectomy 16 years ago. And these sites can re-inflame decades later. And I kind of think that's what's happening, but they don't see anything like that. So I'm just going to see how it goes. But if I get into really bad pain, I'll just have to go to the ER. And I don't want to do that, though. I hope it just goes away.
There's another thing that my wife suffered from. I can't think what, gallbladder. That can get upset with fatty foods and things like that.
Yeah.
And they ended up taking her gallbladder out, but they didn't quite get 100%, and they had to go back in down through the mouth and take the final little tiny snippet out, because they thought it should have fixed everything and it didn't quite.
Yep. The same exact thing happened to my mom. The same exact sequence.
I'll spare you the picture.
Yeah, they've got to get it very precise, but they have to be very careful they don't take too much, because then they can cause you all sorts of grief.
Right.
So I think they err on we won't take quite as much, and then they don't get quite all of it.
And if you don't get that addressed fast enough, you can become septic.
Yep.
Yeah.
So, Stephen, you want to show your board?
Did we have somebody else up first?
I don't know. I don't think so. Ray, your board looks great, and we're looking forward to it.
Thanks, Ken.
Thank you.
I'll send you one when it's done.
That would be good. I'll get a professional picture and give those back to you, and then feature it that way too.
Great, thank you.
All right, tell me if you can see this webpage.
Oh yeah.
All right, so what I'm working on is a Hub 75 driver. This is a GitHub location. I'll put a post up here. I guess I can share it now with everyone, so you can go there if you want. But basically what I'm working on is what can we learn about driving these matrices with the Propeller 2. My panel looks like this in the back. It's 64 by 32, and you can see these chips, rows of chips. Let me back up here. The panels are typically anywhere from 15 to 15, and they are also spaced at different sizes between the pixels. And so the panel you get has different geometries based on that. People tend to gang them. What you can see here is an input connector, an output connector. I'm assuming you can see my mouse. Okay. Basically, you've got 6 lines feeding 2 groups of RGB. So RGB1, RGB2, and they have address decoding for the lines. And so the nomenclature for my board right here says it's a 64 by 32 matrix, and it's a 16 address lines, so 4 bits of address. This is my development environment, and I hand wired the splitter, and I'm trying to make panel work. You can see I'm driving it pretty well right there. Project goals. I want to see what we can do with these things, driving it directly with Propeller. And so basically, see what we can do. I want to do gamma corrected 24-bit color. We'll see what we can do with that. People do, they daisy chain these panels to wall size displays or external building displays. I'm not going that big. My goal is to do 2 by 2. And so what I'm ending up with is I'm looking at performance numbers, and my intent is I'll probably have to go past what I can do with my hand wiring. And so now I have this that I put together, and there's no way I'm showing you my layout details, Ray, because I'm just a hobbyist. I'm not at all professional on this, but at least you see me pretending a little bit. These are nothing more than level shifters, logic analysis connector, and the Hub 75 shell connector that's male pins, and then our adapter here. The goal then is to drive, here's the one panel under test currently. I'm going to gang them together into a 4x4 and then see if I can make the driver do that. So that's really my project. This is the new board. Should be sending it out in the next week and a half and see what I can find. I got to do critical measurements, make sure I like the orientation of this, make sure these are spaced exactly correctly, and then I should be ready to go.
Well, I think this is super fun.
That's what I've been doing so far.
I have a question for you. So what would the Spin 2 code look like driving these in a large format if you had a dozen of them together?
Well, what I'm trying to do with this study is try to decide what data movement looks like within the Propeller environment. And so part of my study angles are going to be am I going to need to use external RAM, such as my HyperRAM? Can I drive directly from micro SD? Even one of my study angles is the SPI on the Raspberry Pi can do like 120 megabit. Can I even drive imagery straight across the SPI interface with custom drivers? And so I'm going to be looking at all sorts of different angles, but I really want to understand what storage formats are going to be most efficient for the data. So the first one I'm playing with is literally 192 longs, is a single frame. And my code sorts through the pixels and puts them out pretty rapidly. That can even be sped up. With my driver right now, I'm driving at about 1.7. I can improve it by 1.7 times the frequency at which I'm driving the panel. So I'm clocking at about 18 megahertz right now. It'll go up to 30 megahertz.
Hey, Stephen.
Yeah.
You can actually go to clock over 2 if you use the, this is a SPI thing, right? So you're just shifting out bits?
No, it's not. This is a direct drive. There's no SPI involved.
Oh, okay. So you were able to do this at 120 megahertz on the, or megabits per second on the Raspberry Pi, right?
I can get to, yeah, about that on the Pi. And but that's communication with the P2. Then the P2 itself is direct driving the 6 pins, and I'd hope to achieve a 30 megahertz rate for data on the 6 pins simultaneously, but we'll see.
Chip, what's going on with this, it looks like SPI, but you've got 6 simultaneous data bits because you've got RGB1, RGB2.
Oh yeah, so there's a huge question of how to organize the data. Do you make it hard to assemble and easy to shift, or do you make it easy to assemble and hard to shift?
Correct. So lots of opportunity here for finding the right way, quote unquote, based on performance needs. And so it's kind of a little research project for me. And the reason for the GitHub is I can continue to post what I'm finding, my analysis results. My initial fat fingering driver, the first one I can put together, thanks again for code review, Chip, is basically, I'm getting about 400 frames per second of 3-bit color. And so that's before I do any gamma correction or expanding the color width.
So 400 frames per second.
At 64 by 32.
Okay.
So you're gonna divide that by the number of panels you have if they're in serial, if they're in a daisy chain.
I see.
And then also divide it down if you want to get more than 3-bit color by using pulse width modulation.
Correct. So if I go to 8-bit, if I go to 24-bit color, it's going to be a divide by 8 on the frame rate. You know, things like that, unless I do a different kind of encoding. So lots of fun. That's what I've been working on.
Yeah, you might have to just, in the end, if you want to make this thing scalable, you might just have to figure how many panels can a P2 singularly handle, and then modularize at that level. You know, so then you can step and repeat those, and have something higher level that feeds data to all those guys.
Absolutely. We see people doing driving a small monitor display. I want to think 10 or 15, 10 or 20 panels, somewhere around there, driving with Raspberry Pi and small Pis at various segments of the system. So there are lots of opportunity here to play. With that adapter, the Hub 75 adapter board, we can drive 3 different chains from the P2 itself electrically. Question is, what can you handle, right? Memory movement wise. And so it seems to be fraught with opportunity to experiment.
Yeah, there's a lot of push and pull and that kind of thing. It's too bad we didn't have something that could just grab like 128 bits from the streamer and then, you know, take every 8th bit, you know, in series and output them. But
I see this as being a good candidate for the loot sharing, where you can have one cog reading your buffer that's in friendly pixel form, and
Right.
it's
Oh.
writing into loot the interleaved 6-bit form that you need to write out, and then that gets read by the other cog to actually output to the panels.
Yeah.
Right now I'm doing sequential writes to the 6 bits, and so getting that to be a bulk write by rearranging, that's going to be pretty easy. Lots of opportunity in the driver to do things. The challenge is the particular chips I'm using on board, it's identified in that post, require overlapped latching with the trailing bits of each line, instead of latching the data in between the line data streams. And so that makes it a little bit more complicated to latch. You're disabling output during latching phases and then re-enabling. So you don't see flickering during latch and things like this. So a lot of fun things to make the display clean. You refresh a little bit quicker to reduce the power consumed by the panel. Each panel is about 4 amps of power maximum. And so by reducing the duration between, I'm at 3.5 instead of 4, but not a big gain, but interesting.
Yeah, when I was experimenting with a similar panel, the only way I could get it to have any significant power was having all the pixels white and then, you know, very bright. And it was like blinding bright.
Yes.
At normal levels, like I could run everything at about 50% brightness and it was still really bright. And, you know, the power is cut in half, obviously. And then when you're PWMing to get real colors and everything, I never saw mine go over 1 amp.
That's wonderful. Yeah, so we're going to get there. It's not nearly going to go that high because of the PWM.
Yeah.
So it should be fun.
Well, I'm refraining from asking for a couple of these boards so I can play along and run code, because I know you said it's hobby and I see your motivation, but this is really cool and it's going to be a lot of fun. And I think a lot of people are going to follow this and want to buy these displays and ride the coattails.
Nice. Well, the whole idea is, one of the goals for my driver is there's at least 4 different major chipsets out there for these panels. A lot of them easier to clock than mine, but what I'll do is I'll put settings at the top of the driver so you can adapt it to your channel, to your chip types. You'll also be able to adapt it to the geometry of your panel and the geometry of the collection of panels that you're daisy chaining. And so we'll see what we can do, right?
Yeah, well, you might have to come out of retirement, because depending on the ease of the interface, this could be a product.
You know what?
Yeah, they make these panels in a lot of different arrangements. There's some that are 64 by 64 all in one panel.
Correct.
And there's some that are only 32 by 32. They're like all different weird variation, not weird, but, you know, alternate variations of the geometry. The other thing that's really nice that I like is that they have some now with much closer, finer dot pitch on the pixels. Correct. So like the LEDs are closer together and you get a nicer image, but obviously the panel's a lot smaller.
Yeah, mine are 3 millimeter. They go down to 2 millimeter on the panels. And I think, Johnny, back you're playing with a 32 by 16, right?
Yes, that's the one that I got out of the plastic pink purse.
Exactly.
And it's 5 millimeters on centers. I'm just measuring it now on the LEDs.
P5.
So it's not very dense, but, you know, for my, you know, my desire we were talking about, you know, I want this to be on a backpack for conferences. I think that'll be fine.
It's fun. People are taking the flexible ones and putting them in face masks now. I don't know how you breathe, but hey. Tops of hat, of course, right? Yeah.
Stephen, there's some helpers, you know, because this problem of having to split bits and reorganize them,
yes,
we've considered before. And so what we did is in the instruction set, we have these split and merge instructions.
I saw those on various different boundaries. I didn't see a direct match yet, but I'm studying them for playing with.
Yeah, that I made some diagrams, some nice drawings in some Google Draw program that shows like the transition, where the bits come and go from. But see, it's possible that you could stack a few of those together in some fashion and achieve just about any combination.
Correct. So it should be a lot of fun to try. So yeah, I can see I've got a lot of work ahead of me.
Now your bits, you say out of how many bytes do you have to pick every 6th bit, or do you just dedicate a byte to what is 6 bits, or do you need 6 bits in the end because that's the serial channel streaming?
Some people, for Arduino purposes, they take the 6 channels and lash them end to end, so it's a single stream, 6 times the length in a single panel. In our case, if we're trying to achieve frame rate, we drive the 6 lines independently. So in my case, it's a 64-bit wide panel, so it's a 64-bit length, and we latch on the last 3 bits of the 64. Since they are RGB, and since it's literally 2 longs per line, I can get away with allocating each color to their own set of longs. And so I can do a whole panel in 192 longs with 3-bit color.
Yeah, that would be ideal, right? From a software side, you want to just have the RGB bytes with maybe a spacer byte, then 3 RGB bytes and a spacer byte.
Yeah, and so I've got, and I'm not even using spacer bytes in my case. And so I'm using code to merge since I'm driving all 6 lines independently, 4, 6? Since I'm driving all the lines independently, I don't care where they come from. I'm not using the write all 6 pins at the same time commands yet.
Oh.
At that point, then I'm going to care about data organization a little bit differently. And
okay.
So, yeah, I definitely have to play with those instructions, and then I probably won't release the board until I understand that arrangement and which instructions work.
Right.
Right.
Can you
do that?
I missed probably, but could you describe what these 6 signals are? There's some kind of serial data lines, right?
They're nothing more than they're directly feeding into shift registers, 6 independent sets of shift registers. One, I have 3 RGB top half of the screen in my arrangement and 3 RGB bottom half of the screen. So 16 lines at the top, 16 lines at the bottom. And so you drive 16 groups of 64 bits out to each of the 6 points.
Is there a separate clock signal? Is there a separate clock signal, or is it just the 6 bits at a fixed time rate?
Nope, it's a separate independent clock. So the data is clocked into the shift registers on, I'm guessing, the rising edge.
Okay, so it's technically 7 bits because you have to clock.
Negative, because the clock is running simultaneously.
Yeah, no, I mean, I'm just saying there's a 7th wire going to the panel for the clock.
We're not finished yet. There's also output enable, which makes it 8, and then there's latch, which makes it 9, and there's 4 bits of address, which makes it then 13. Which is why you see me using 2 connectors on the eval board. So I have the 6 bits of data coming out one connector, and I have the address, latch, clock, and output enable coming out the other connector.
John Titus threw you another challenge. Could the panel self-organize, recognize their neighbors, and act accordingly?
That'd be really sweet, but there's no readback from those panels, the write only.
Yeah, the panels are just effectively passive from your perspective. Like they just accept the stream of bits and display whatever you fed it.
Now, if we individually backpacked the panels, that'd be a little overkill for Prop 2. If we backpacked each of the panels, then you could make them organize them because they could report in and deal with it. But somehow you're going to have to get the data column. That communication is just fun.
Yeah. The way to think about it is when you have multiple panels, it just is a longer serial stream that you're outputting. Okay. So instead of 16 rows of 64, you're doing 32 rows of 64 or 16 rows of 128 for 2 panels, right?
In the case of my 4, it's going to be 16 rows of 256.
Right. And different panels arrange them differently, but yeah.
Correct. Correct.
Anything else on that, Stephen?
Nope, that was it. I've spent more time on it than I thought I would. Thank you all.
Everyone's enthusiastic about it, so looking forward to it. Let's see, Chip, since you're back in action, 2 things. So P2D.
He's on the phone.
Oh, he is. Okay. All right. So maybe we'll do P2D2 update, and then we'll come back to Chip for Brian's question about sine waves.
Hi, Ken.
How's it going?
Hey, yeah, good. I've just I've got the camera focused up on the
It looks good.
P2D2 I picked up last night, and this one's a bit rough. I haven't touched it up yet, but it was just manually assembled, and yeah, so it's all come together quite nicely. And I've even made up a P2 panel. I haven't done the hyper RAM on there yet, but yes, no. So that hyper RAM it hasn't been loaded yet, and I haven't got the USB-C connector on the P2 panel. But I'm looking forward to just checking out the P2D2 itself, making sure everything's right on that one, and also too with meshing that with the P2 PAL. So that P2 PAL would just go flipped around and on the back of the P2D2, so it becomes one tiny module. And as you can see, it is a tiny module. We have the old P1 in DIP 40 right next to it. So it's not very large at all. And the other thing too is some are worried about 100 mil headers, but of course I'll just move this along a little bit. We have another little board there, and so the P2D2 surface mounts to that, and that just becomes just like the old P2D2. We have Raspberry Pi header up there on the top 2 rows, and then the A and B ports on the next lot, and just like the old P2D2. So you don't lose anything.
Can the P2 PAL go on the bottom of that board that has the 100 mil pins? Awesome.
Yep.
So you create a sandwich.
Yes. Yeah, exactly. And so the whole idea with that one is so we can put it on the back there. You can see a couple of through holes there even, but basically the surface mounted up through there, and you can do whatever you want to do with that in terms of mounting, and that makes it a lot easier. So and I haven't put these 2 together yet because, well, you know, I still need to test them out anyway, and I did it last night, so I wasn't very tidy with it, but I just manually assembled that one, and I've got the stencils for it and everything else, and I'll do up the panels. I put 6 on each panel just to keep it small enough for me. But when it comes to production, when I get it assembled elsewhere, it'll be whatever suits them anyway with getting that manufactured. So it looks pretty much like the old P2D2. If you remember that I'll just hold one of these up here. I'll put that across there, perhaps. The old P2D2, that one's a reject one board, but it's just the middle section of it, but it's been squeezed in a bit more so that the inner row of 50 mil pins, 1 inch apart, that was Ray's fault. And I just had to squeeze it all up a little bit more, but it's all in there now. And so that's good. And of course, I use a different USB, micro USB connector now. I have one where the connector flips around the other way, and it's also a bit easier to manually solder as well, or inspect at least. And otherwise, doesn't look like a lot of difference internally, though. There's a lot of difference. As you can see up in the top right-hand corner of I'll try to get this a little centered a bit better up on here. See if we can do that. Top right-hand corner, you can see the metal can there. That's the capacitor, and to the left of it is the actual real-time clock chip, and then there's the crystal, and then the clock generator in the little 10-pin T-SOC. By the way, too, I noticed that on some of the PCB designs only have a very small footprint for the actual flash chip. And I found that that suited my regular flash chips, but some of these ones come in very wide packages. So as you can see, to the left of the board there, to the left of the P2, I have a wider package there because you can get those in narrower packages as well, depending upon the density. So that accommodates all those parts. And what's been left off this one is really nothing except the reset switch, which was off on the header side. And the reset switch instead is, as you can see down on the P2 PAL down here. I'll see if I can point to it. Doesn't really work that way, but right around there. Point to it properly. Right about there, it should be the reset switch when I get some more of those. Right above the ESP32 module itself. And that ESP32 has the serial port, another serial port, and also the H-SPI port as well. That's connected up to it. And I'll just bring that up a little bit more. I'm monitoring the monitor here at the moment to make sure everything's right. And so you can see we have the pseudostatic RAM. There's an 8 megabyte pseudostatic RAM right there in the middle there, right next to the WS2812 DB LED, and we have 6 other LEDs, a USB-C connector which isn't fitted, and that's mainly to allow me to do HDMI or VGA or anything else up through there, since it's a very compact connector. And then I also have, on the left-hand side, I have a push eject socket there for the micro SD, and basically that replaces the one on the P2D2. And then in the top left-hand corner of the P2 power, we have we can have an extra capacitor in there or a little battery the exact same size and footprint. Work that one out. It's a rechargeable lithium battery would last a year in standby, easily with a 40 nanoamp standby current on the real-time clock. So that's the unit now, and of course you can this is also too the I'll just put that across there. Perhaps we'll see that easy enough. Nope, we don't. You need a better camera. Okay, here we go. So that's the little serial port 2 module that I decided to make up as a separate module. I like to use those things, and that uses the same chip as the P2D2, except I use it in the TSOP pack, and just for the extra I/O lines, and the QFN 24 QFN is not really available. It's either the 20, 24, 28 pin, whatever that one is, or the 20 pin QFN. And I've made that up on there as a general purpose module. And it also has the I2C bus to talk to the chip. So it's a smart chip with watchdog, reset, power monitor, etc. And also an optional RTC circuit on that. So that's what I've got at the moment. And I'll just be busy playing with that. But it sounds like everyone's really getting into the hardware now. So we're really starting to develop some P2 product here.
Are you hopeful this is the final revision?
You know, the other boards worked. I just, well, you know, spent a bit of time on that USB serial, and in the meantime I decided I'd rework the reset circuit. And in this case I have a pull down resistor on the P2 reset, and so the P2 is just not coming out of reset until it gets a power good signal, basically enable or run signal from that UB3. I did various tests on the earlier version, and I did earlier tests, and just ramping the power up and down, you could see that there could be a problem with the P2 coming in and out of reset with that power going up and down. And so I decided I'd clamp it down with the pull down resistor, and the UB3 chip would have to power up and then also check the power, etc., and then issue the run signal for the P2. So I get a very, very nice reset signal for the P2. And of course, the the UB3 chip is also generating the reset pulse if it detects a proper serial load pulse, not just a transition. So it doesn't depend upon a capacitor or a transistor circuit. It's a smart reset. So that makes it very nice. I don't have to worry about disabling the flash or the SD boot. And once we do a serial load with that pulse, it will disable that and load up the P2 automatically.
Well, I know several of us are enthusiastic about you paving the way with the UB3 exploration so we can free ourselves of FTDI at some point.
Yeah, it's incredible. I mean, if I can buy these chips for $1, it's like, well, no, that's a small volume. And look at the FTDI, and all it is just dumb serial. And here on this one here, I can do 8 megabaud serial as well, and then I have a lot of other controls I can build into it, so I can really customize it, because this thing, we can load a new firmware into it via the USB, and on here, on this, even on this particular board here, the little micro port U-port board, USB port, well, that's not working too well there. I'll just move it along a bit, but that allows us to short out 2 lines if we ever want to reload the firmware, but you can't erase it accidentally. It just won't happen, and so that allows us to plug that into breadboards. I'm using one at the moment. I've hooked up to, I'll just put it up in view here. I'm using one hooked up to my RISC-V. Let me get it in the right spot. There we go. If I remember where the camera is, I'll be right. Okay, there we go. So I've just got one hooked up like that, just as a test unit. Doesn't really focus right well there, and really I don't have time to play with any software. I just have to get this hardware going. I really want to sort out the production of all these units, but just making sure that they're fine. I like to always assemble my boards, my prototype boards. Then I can see what can be improved in terms of components, placements, etc. The PCB design itself. Looking at in terms of manufacturability, which is a thing these days. It used to be that I'd ask the PCB manufacturer, what can I do to make it better? You would never get any feedback. Now apparently it's becoming more of a thing that you get the feedback. But I always look at the when I make the board, I'll get the feedback straight away. I can see this didn't turn out too well. That's too close over there, etc. And this is a 2-layer design, remember? So the back of it is, well, there's nothing much on the back of it here. I'll see if I can put it up here as well. But back of the board is mainly options if we run it as an option. Okay, so that's the back of the board there. It just allows us a couple of different micro SD options. But once we put the P2 PAL on there, that doesn't matter anymore. But we also have options there for extra backup capacitors and oscillator options, etc. And of course, we can see that heatsink pad going straight through to the P2 PAL or through onto the 100mm header board. So that's where I'm at the moment. Can't report much. Once I do, by the way, I'll just tell you a little story. That P2 PAL there, I was talking to Ray a few weeks back, and I said, I might put a little VGA connector on the end of it. He says, no, don't worry about that. And here's Ray, he's got a VGA board. So yeah, it's like, it wouldn't have suited this board really. I just thought I could have a breakaway option on there. But we can see that in terms of, I do have other boards. I'll just try to get this back again. Okay. Must be an easy way to get these cameras right. So anyway, that's the board there. And just talking about those VGA boards, for instance, I used to have ones for the P1, which was just plugged straight into the back of the monitor, P1, and had dual 485 and switching regulator. And I could run that from 4 wires, two wires for 485 and two for power, 24-volt power, and I could string them around a factory, hook up monitors, and even had a USB connector on there, so I could plug a keyboard into it as well. So, so I might do something like that as well. Different versions of the P2 power with different connectors on there, but the USB-C connector that we see there, I've got to play with that yet, but I should be able to plug in a cable and plug that straight into a VGA monitor or HDMI. I will have a little adapter type PCB just on the back of the connector to handle that. So, how's it look?
It looks good. Thumbs up.
I think it's pretty easy to align this picture here when I look at the, I'm looking at the screen on my monitor, but I need to look at it on the camera. It's a bit easier, then I don't have the latency then. But that's it. So it's real, it's out there. I have the stencils. The stencils look good too. But I'm only aiming at doing limited production with that myself, and just to get them out there. And in the meantime, once it's tested, I will be looking at what I need to do to get a few hundred of them made up. I'm pretty confident that I'll be using that first run.
All right, another one for Team Oz. Hey, Chip, let's go back to Brian's question since you've returned. Unmute yourself. Generating 2 sine waves on 2 different pins that are in phase with each other.
Yes. So depending on what the bandwidth of the frequencies of these sine waves are, if it's low, if it's audio or below, you can just do that in software and use DAC modes and use the Cordic thing to compute your sine points and output them. However, if it's going to be something high speed that goes up into the megahertz, then it would be better to use the streamer in DDS mode. And you can output up to 4 phases or 4 different frequencies as long as they're multiples of each other.
What tests I've done so far, they're all going to be 60 hertz roughly for inverter frequencies. Started a cog running one and started other cogs, but pulling from the same frequency updater. The code that you wrote 2 weeks ago, the cog pulled its data from a frequency variable in the hub that was updated. I think you went from 50 to 60 hertz, sweeping backwards and forth.
Right, I remember that.
Okay. Well, using the same frequency value, I started a second and a third cog, and it was hit or miss whether they were in phase with each other.
Okay, all right. Okay, so at some point, let's see, I'm trying to remember, did that thing use the streamer? It might have, right? Or did it use?
Well, you referenced the Gertzel in it. I don't know if I'm saying.
Okay, so it was using the DDS. So those signs are 8-bit in quality. Let's see. You can do, for 50 or 60 hertz, you can just do all that in software and use 16-bit DAC modes and update that thing at, easily, a couple 100,000 to 1 million samples per second. Okay. Maybe what I should do is write another version of that that's just in assembly language that uses, like, it waits for the clock so that every so many clocks it updates your outputs. That might be better because then you could, you could add any frequencies you want. You could control all the phase in software. The way the DDS works is the phase is a function of like what you put into the lookup table memory. So do you want to do something where you want to be able to like dynamically control the phases between these signals?
No, the app would be an inverter, converting DC to AC for household use. But rather than just a set wattage, I would use a pin to drive a set of FETs in banks. So if the power use, if the load increased, I could turn on another pin and open up another set of FETs and feed that in, effectively matching the wattage with the load. But they would have to be in the same phase once I started them up. Otherwise, I could just start a bank of pins all running and just feed them through a relay. Say 6 pins, turn 5 of the relays off. I'm putting out 400 watts. And if all of a sudden somebody plugs in a refrigerator, the load cuts, turns the other relays on. And now I've got, quadruple the wattage coming out, that sort of thing.
Right.
And I mentioned this out of curiosity. Like I said, this is a long-term project. Right now, I'm just for getting used to the P2. I'm just starting with the DHT11 temperature sensor, trying to port the P1 code over to the P2. That's what I'm doing mainstay. This was more of just a curiosity if it was possible to do. If it comes straight from the pins, that saves me a whole lot of hardware to pull off a simple inverter. Well, it already does. The fact that you can generate a sine wave from the smart pins, so I know once I get down the road and I'm actually putting some sweat into this project, the P2 is going to be dynamite for it.
Okay, well, what I'll do is, so what you want to do sometimes is you want to be able to match the phase up, right? Is that what the goal is?
If you started a sine wave on pin 1, and all of a sudden, and it's driving a bank of FETs, and all of a sudden the power requirement doubled, and I've got pin 2 hooked to a second bank of FETs, and their output, of course, goes to the same output as the first set of bank FETs.
Right.
So if I open that second pin up, I don't want those FETs firing at different times, or there wouldn't be an AC.
Oh, okay. So what you want to do is, okay, so you just want to have like a single phase signal that you want to be able to gate across multiple pins. Is that right?
Correct. And I could use hardware, a simple gate system to take one pin and maybe even split it up across 3 or 4. But I was thinking how simple it would be to just put an op amp on each pin and turn them on when
Okay, well, here's all you got to do. And you only care about a single phase. In all your system, you just have a single phase, right?
Right. I've heard of some people who would balance the load by adjusting the frequency, from 55 to 65 hertz, but I don't really want to do with that. 60 hertz dead on and just add more power.
Okay, so here's what you can do. We can take that program we made and we can make it so the entire lookup table is all the same wave, right? So there's no different phases. It's all one wave.
Well,
what's that?
That answers my question, Chip. And if there's other people interested in this, Godspeed.
Okay, well,
but if not, I'll come back down the road when I'm really when I'm actually putting some sweat into this. It was just a hypothetical question, really, to see if it could be done.
Yeah, well, I think the way you could do that, if you had the streamer output 4 identical signals, you could then enable any DAC on the chip to turn on and begin to output that sine wave. And to know your phase, you could set a streamer rollover interrupt so that when the streamer rolls over, it interrupts, and then that would give you time to go, okay, who do we want to turn off and on for this cycle? So you could output that 60 hertz on all pins simultaneously and selectively on any one you want.
Now all I need is a 50-foot solar panel. Thank you, Chip.
Yeah, you're welcome.
Chip, can I ask a question about this too? I really enjoyed your talk on audio and the signal processing. Reviewed the tape again, and you know, I couldn't find the code. I mean, it was basically your screenshots that you showed on the screen.
It should be in the latest zip file. Let me go look.
Yeah, I'm sorry, it's my problem. I don't know where to look, and that often happens.
Let's see. Yeah, here it is. It's chorus crossfade. So it's in 34Z. So I think I've got 34Z up on the site, right? Let's see. Let me go. Okay, let's see. Yeah, I've got 34Z. So if you go to the sticky thread, it's the second from the top. It's called Peanut Spin 2 latest version.
Yeah.
It's in there, and the files that are of interest are going to be, whoops, where'd I put it?
Okay, I see it now, the zip file top. Does that include the beautiful plots that you made and how you made those? Those were really...
Yeah. That's in this. It's in the chorus crossfade and chorus simple. So there's chorus crossfade pitch bend and chorus simple pitch bend.
Excellent. I'll download that and play around with it. Thank you.
Oh yeah, yeah. I'm glad you liked it. I've been working. I was almost done with the documentation for all the debug stuff, and I started thinking that I really don't like the way all those jaggy lines look that I draw for signals. So I've been working last several days on an anti-aliasing algorithm for drawing lines. Let me see if I can share a portion of my screen here real quick. Let's see, share screen, advanced portion. Where'd that portion go? Oh, I see it, it's way over here. Okay, so I'm gonna drag this to here. Now, do you see that?
Yeah, I see that.
I don't know if you can see or not, but it's everything's anti-alias. Do the lines look really smooth?
Yeah, they look very smooth.
It makes a huge difference, because when you have jaggy lines, you're missing. But the way this anti-aliasing works is, let me show you if I can pull up a. You get many sub-bits of resolution. Okay, so I'm going to drag this thing over to here. So you see this, right?
Yep.
Okay, so that's anti-alias. So look when we zoom in on it. You see how there's like 3 pixels?
Wow.
So it's kind of a way to fake like line placement. And it works beautifully. Let me see if I can get this. So you can see how that fades. See, so as that signal drops all the way from 63 to 0, it's crossing 2 X points, right? But it does it by this fading method, where it kind of like uses alpha blending to place the line. So then when you zoom out and you go to like regular, let's see, I think that, no. Let's see, what is regular size? Anyway, you can see when we get down there, it looks like a perfectly clean line that's just magically moving only 2 pixels from top to bottom. That's due to the anti-aliasing. So most like every video game uses this kind of technology to make things look good. But the weird thing is the Windows API, there's something in Windows called GDI+, but I don't know if I can get to it from Delphi. I read conflicting things. So, and then I looked at all these different programs that do this drawing, and it just looked so overwhelming. So I figured in the end, maybe I could just make this. So in like a day or so, I had it working. But now there's tricky stuff that goes on with anti-aliasing, because as your step size becomes really small, what happens is you don't have enough room to anti-alias. So you get back to just jaggy pixels. So that's why you can see when that blue sine wave compresses, it looks really, really clean. Let me grab it here. See that? Because there's plenty of distance between samples, so it has a lot of opportunity to anti-alias.
Yeah.
But when you get to the top, like let's see, when we'll wait for it to slow down and spread out, and I'll stop it. Whoop. You can kind of see at the top, it's not as nice looking because, and this is what I'm working on. I'm trying to see what subtle stuff I can do in the algorithm to make it so that the aliasing always works pretty well. But it's a funny thing because there's direction involved in aliasing. You've got to do your alpha blending like perpendicular to your line direction. But anyway, I just wrote some code in Delphi. It's not even that big, but it does this.
That's beautiful.
So I'm going to put this. So now all the plot, like those that crossfade plot that I showed in that demonstration, it had a lot of jaggy stuff. All that's going to become smooth, and all the shape draws will become anti-alias. So it'll look. It kind of hides what the actual resolution is. You know, you don't really know, but it makes things look just very clean or very precise. Anyway, I'll stop sharing this. That's what I've been working on.
It's fun to see the resolution of the display cleanup, Chip. That's fun.
It's really like, it's like magic, you know, it's like with 8 bits of, you know, R, G, and B values, you can like, you have actually kind of like 8 sub bits that you can move things around in. But the trick is you can't have something just 1 pixel wide, because it'll start to, as you're drawing it, where's the camera? It'll go like this. It doesn't look right. So you have to have it at least 1.5 pixels wide. So I express everything in 16 bits, 16 sub bits per pixel location. I really only need 8 for the color blending, but I use 16 because I wanted to be able to add into my, like if I step the X every opportunity, or every time I draw a slice, I have to move Y some variable value. So 16 sub bits allowed me to have like 1 adder value for Y, so that as I move X by 1, I step Y some fraction of that. So I had to go to 16, but this is the same thing we could do with like the DAC, you know, for audio signals, all these kinds of like funny tricks to extend the bandwidth without having any like higher bandwidth base point, or the resolution, dynamic range, I guess you could say.
Chip, what's your next effort after this? Not a leading question.
Well, I think next I'm going to climb Mount Everest.
I was thinking smart pin documentation.
I have some boring things I have to do, like, so Ken has organized a big product launch, and I need to get the data sheet ready. There's a lot of stuff that, you know, it's just boring stuff, but I really like working on this fun stuff. And I also want to make the debug stuff become interactive, so we can send and receive data. And once I have that working, oh, we're like a breath away from having a single stepping debugger, because everything, all the fundamentals will be in place then. And Jeff, I haven't gotten together with Jeff lately, but he's working on an event-driven serial thread that should run with our Delphi code, so that we won't have to pull serial. It'll tell us when something's up. So that's going to turn things around a lot and improve performance quite a bit, get rid of all kind of latency problems. Yeah, well, not, I mean like response latency issues. I was going to show something. No, I can't remember. What was I going to show you guys? Oh, I was going to see if Wendy got back about the derating for the frequencies, because, you know, we designed this chip No, I don't see anything. I think she probably wants to do it because that's her nature, but she's probably pressed to do other things and maybe she can't get to it. Hopefully they don't want more money to answer the question.
Yeah, I was thinking she has to answer to the business guy.
Right, right. She has to account for her time. But she would do it for us though, but I don't know. We'll see. I asked her the other day to just let me know what's up. But once we get that data from her, we should be able to curve fit and come up with like a derating. So, I mean, no one's ever going to get the chip up to 150C, I think. That's probably not going to happen. So we got to know like how fast can it run at, you know, and every point in between at 25C and minus 40. Although, you know, the chip self-heats, so it's never going to run at minus 40 unless you started at 0 Kelvin maybe.
I noticed we don't have Jeff here, but just as an aside, in my own development, I had to move back to PNet because I found out that the current alpha of Propeller tool was unstable for what I was trying to do. Mostly paths and stuff, so.
Wait, explain that again. I didn't understand.
Well, I said the Propeller tool turned out to be unstable and not diagnosing some problems.
Oh.
Just not generating code correctly, so I went back to PNet.
Okay.
The current alpha state of it. I mean, we expect that. I'm just giving you a heads up that it is.
Okay, okay, thanks.
So it'll be fun when Jeff can finally roll in what you have.
All right.
I think I'm using the right name, aren't I?
Okay, so yeah, we'll look into that. I'm almost to the point where I'll be able to give Jeff a final slug of stuff to you know, enable him to kind of make like a kind of run for the completion where we're not going to have to do a lot of rework later on.
Oh, nice. Yeah.
It looks like Jonathan Titus got off. He had written some documentation that I haven't proofed yet, but I was thinking maybe he could explain that to us, but he's gone.
Is this an upgrade on the smart pins?
You know, I don't know what it was.
Nice. One of the things in the smart pins document, I should talk to John directly, is the images are overlapping the text. So I've never been able to get a good generation of a PDF of the document itself.
Oh, so you mean the Google Doc?
Yes.
The smart pen.
The inline images were always overlapping parts of the text, and people have been noting that for a while.
Oh, so I haven't noticed this. This is somewhere in the smart pen description?
The shared Google Doc, it sounds like.
Yeah, it's in the shared Google Doc. I basically generate PDFs and I work from PDFs rather than going to the online doc, and then I watch for changes. And it's nothing more than going to view and then print PDF, right? But that one gave me some grief because I'm missing top parts of lines and bottom parts of lines, and heaven knows how many other lines are covered.
Can you point me to like a page? So there's a problem with the documentation where images are obscuring text. Is that right?
Yes, that's correct.
Okay,
And specifically the pins document, the smart pins document.
Oh, you mean those like pad IO modes?
He's got graphics in there. That are,
I don't know if I'd worry about it too much, Chip. Just be aware, but normal workflow, you finish reviewing John's stuff, then Stephanie will sweep through it and take care of all those issues.
Okay, well, is this in the Rev BC? Is it in documentation V33? That's what I need to ask.
Okay. It was certainly the latest I had available when I looked, which was a week or two ago. About the time of the presentation and just after his presentation. Let me see if I can pull up the... So, yeah. Here, I'll share screen.
Okay.
And I think, yeah, well, press the share button, Steve. I think you're seeing the screen, and you can see like right here.
Oh, okay, yeah. Oh, okay.
That kind of stuff is,
John
that kind of
Titus
stuff is going on all over the place.
Okay, okay. So this is.
And so it's kind of hard to read it for what we want to read it for.
Okay. Okay, I'm going to take a screenshot of this.
Oh,
and I'm
sorry.
Wait, put it back for a sec. Let me see if I got it. I might have captured it in time. Let me see here.
Sorry about that.
Oh no, I got it. I got it. So
easy to get to anyway if you need it.
All right, so I'm going to crop this down and save it and send it to him.
Yeah, just if he can go through and clean those, then we can use the document as is. And every time you communicate him, please with him, and I will too, let him know that we really enjoy what he's doing. That's an amazing.
Yeah. Okay, well, let's see this. So this is John Titus. Okay, all right, I'll send that to him.
Yep. Yeah, we're kind of having to read around it.
Hey, do any of you guys know? Do any of you have any practical experience with algorithms for doing like 2D anti-aliasing? I think Roy, you know, Roy knows all this stuff. His job is to write
yeah,
the rendering engines for a lot of these video games that, like, he worked for Valve for a while, and then before that he worked for Sony Online Entertainment. But his job was he completely authored the 3D rendering engine that those games used. So he knows all about shading and everything you need to know to build like a 3D graphics engine. So for him, 2D anti-aliasing would be trivial. Maybe I'll ask him. Any other questions or anything?
I just downloaded the Google Docs document that's in the group chat. That came down as a DOX file, not a PDF. Is that correct?
Probably if you're saving it locally, but you can also print it directly when you're viewing. And yes, the current document has the same issues.
Oh, okay.
I tried to open it, but my computer's like all connected where it tries to open up a new version of Brave browser, but then doesn't show the final screen. So I'll have to copy. Let's see.
Yep, so it even starts happening on page 4. So easy to find. Oh, that was the browser. Then I go to Google Docs. Yeah, so I like your idea, Ken, of the workflow. It's good separation.
Yeah, we have a process. So I'm trying to steer Chip there. If there's somewhere else you think we got to send them other than documentation finalization, if anybody has any input on that, as if we have control over him, but we can steer him a little bit.
Well, it's just fun watching what he does constantly. So making us look like we should be working hard, Chip.
Yeah, I know. Sometimes I feel like I'm kind of lucky. I get to live as a dolphin for the most part.
Oh. Okay.
You know, okay, one thing about all this anti-aliasing business is this is great for if we ever move everything over to the chip itself, we can use all this kind of know-how to do nice graphics. And I'm also thinking that really, you know, 8 bits per pixel or 8 bits per RGB are pretty rich, but 5, you know, we have a 565 RGB mode.
I saw that.
And I wish I had also made a 555 because this awful thing goes on with 565 where as you climb the white, you switch between purple and green, purple and green, purple and green.
Can gamma correction tables generated for 6-bit versus 5 take that into account for us automatically?
Well, we don't have any gamma correction, right?
But I'll be adding that in the driver. So I translate all the values via gamma correction first.
Oh, okay.
Then I PWM those. So maybe I can take care of that difference there.
Yeah. The thing is, though,
that's still going to be an power 2 order magnitude off. Maybe that's not significant.
You see that the trouble is the way we make 8 bits is we take 5 bits, for the case of the 5-bit colors, we take the 5 bits and then we take the 3 MSBs and just tack them onto the back. That way the whole thing climbs all the way from 0, 0 in 8 bits to FF to 8 bits. And then in 6 bits, we take the 6 bits and we add the 2 MSBs to the back of that to get 8 bits. The trouble is I don't think we can get parity in actual level.
Correct.
And this is the problem. This is why those 565 displays, if you're going white, you always see it kind of like, as you climb the white ladder, it's going like a little bit purple, a little bit green, a little bit purple, a little bit green. It's awful, you know, but if we had a 555, then I think that would give us, instead of 8 subpixels per placement, we'd have 5, instead of 8 bits of subplacement, we'd have 5 bits, which is still really good. You know, so a 5-bit alpha blend would have been fine, or, you know, 555, but the only thing we have is like, that we're going to do this nicely with is a full 32 bits per pixel, which is kind of wasteful. And it's going to require a lot of hyper RAM to make a display, and there's more data to write, but then we can do the same thing we do on the PC. It wasn't me. Not that time.
Hey, I'm late to the party.
We're wondering about you.
Yeah, just got in.
Chip, I also wanted to ask a question about the system clock. We've discussed multiple times about the various the functions that you make, like get second, get millisecond, get microsecond. If we just had the capability to do simple 64-bit math,
I know.
We could take the whole system clock and we could get times out to a millennia in clock cycles.
Right.
Now, I think it was it Peter that said he was in Flex, he was going to try to implement 64-bit. I didn't know. That was when he had his talk a long time ago.
I don't know if Peter's done anything. Peter, where are you?
Who am I talking about? Maybe it's not Peter. Who wrote Flex GUI?
Oh, that was Eric Smith.
Eric, rather.
Yeah,
I'm sorry. Eric had mentioned that his version of C is a complete 1999 version of the C programming language, except for the long variables, 64-bit variables. And even if he was able to do simple 64-bit integer math, like multiply and divide, you get that system clock out as far as you want. Now, I did play around with the little function you have in there called, I forget what it's called, 64-bit
yeah, MulDiv 64, yeah.
Yeah, but that wouldn't do what I needed.
No, what you need is I can make what you need. It's a subpart of MulDiv 64. So instead of taking the 64-bit product, we would just take the 64-bit count and divide it. That's all we can really do with a big value like that, is just divide it, right?
That's correct.
Yeah, we're going to have to divide it, and you know, it will run out. The 64-bit counter won't run out for a couple thousand years, but if you're dividing by the clock frequency, it will run out after maybe a couple years. How do we calculate that? We have to get my Microsoft calculator up here. Big ugly one.
Well, even you know, several hours would be great.
Yeah. So if let's say we're running at like 300 megahertz. Oh no. I think I exceeded its ability. It doesn't go up over 64 bits. It thinks all ones is -1. Well, okay, I can do this differently. I can just say, let's see, 7 FFF, FF, FF. There's 32 bits. Is that 32? No, that's too many. There's 24. No, wait a minute. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So here's a high 64-bit count. I'll convert that to decimal. Then I'll divide it by, say we're running at, well, we had to have the number. So say we're running at 300 megahertz. So I'm going to divide by 150 million because I already cut the top down. Okay, so this is going to give us this huge number of seconds divided by 3,600 is this many hours divided by 24 divided by 365. Oh, it's still 1949 years. Well, yeah, I guess that all makes sense. It doesn't really go away. Okay, so yeah, we'll have plenty of but no, the trouble is if you divide, if the top 32, let's say you're going to divide by 300 million, if the top 32 bits of the 64-bit count gets to be over, or 300 million or over, then it's not going to work anymore, right? It's gonna overflow on the division.
Chip, I'm going to pass the host control to you. I got to move on to something else.
Okay.
Yeah. Before you go there, Ken.
Yeah.
The problem with the documentation, I think I found a solution.
Mm-hmm.
It's quite simple. I posted the link to everyone just a little bit earlier. I can do it again if I need to. But if you click on that link, and you click on that, I'll post it again right there. If you click on that link and then go to the center of the documentation and just click on open with Google Docs, then the images are correct.
Oh, I see. Maybe Stephen was downloading it as a Word doc.
No, I saw the same images in Google Docs as well, the same overlaps.
I don't know. I just tried it. I mean, it looked fine.
Because I did the same thing. I changed to Google Docs as well. I actually printed the PDF from Google Docs.
Okay, well, I can do a screenshot right here. It looks normal.
Nice. I just tried, but I'll of course try again if you're saying it should look better. I'll be glad to.
And then I did a PDF that looks normal too.
Okay, good. Thank you for checking.
All right, thanks.
I did the same thing, and mine doesn't look normal. The figures do overlap too, so I don't know what the difference is.
Maybe something to do with screen resolution. I don't know. But
are you using you're still using web-based Google Docs, right? We don't have a choice to do anything else.
Right.
So you're not using some other version?
No.
Okay. Yeah, there should be an explanation for the difference. I don't know what it'd be.
Okay. Thank you all. Have a good evening.
All right, we'll see ya.
Goodbye,
Thank you.
Bye now.
Hey, Chip, can I ask you another question about the system counter?
Sure.
So in the doc